This is a lecture on Unit 2.01 for Computer Programming 2, and it's on classes and structures. Classes and structures are pretty fundamental to object-oriented programming. They're powerful because they allow programmers to encapsulate data and behavior that belong together as a logical unit. Today we're going to look at classes and how they're used in C#. We'll also create a structure and compare the two type systems. Now you can see here that I'm in Visual Studios and I have a simple Windows form. I have two text boxes and a button. When I run my program, I want the top text box to contain information about my student, and I want the bottom text box to display their schedule. Now, the way I'm going to approach this is I'm going to create a student class, and through that class, I'm going to fill my text box with information. I'm also going to create a structure that is going to contain a schedule for the student. So let's get started. So I'm going to go to the Solution Explorer. I'm going to right-click over my project, and I'm going to add a class. We're going to give that class a descriptive name, student, with a capital S. You want to always begin classes and structures with capital letters. Okay, and here you see the skeleton for a class. I have my namespace, I have my class, and the name of the class. Everything that goes between the braces is going to be the actual code for the class, which I happen to have on the clipboard. I'm going to paste it. Okay, and we're going to talk about the class just for a few seconds. There are two members to every class. The first members are data. Here you have the data members. They're called fields. They're also known as instance variables. We use any information that is pertinent to the running of our program for every object that we create, or everything we need to know about each student that we create. We're going to include that as a field in our class. Notice it has an access modifier of private. That's to protect our fields. We have the data type and the identifier just like a regular variable. Okay, so those are fields or instance variables. The rest of our program is going to define the behavior of the class, and those are called methods. You can see that we have 4 methods. 3 of these are special methods. These 3 methods are special because they're called constructors. You can always identify a constructor in a class or a structure because it has public in the name of the structure or class. Now you can see we have the same name for 3 methods in our class. Those are called overloaded methods, and the only reason we can do that, we can use the same name as long as we change the parameters. They have to have different parameters, and you can see they do. Okay, so if you look at between the parentheses, we have a clear nothing that is being passed. We have one where everything is being passed, and we have a constructor where only one field is being passed. The first constructor is a special constructor called a default constructor. In C# and some other major object-oriented programming languages, if you don't explicitly type a default constructor, the program will implicitly create one for you. You can see that all the instance variables are assigned to empty if it's a string, 0 if it is a number, and it would be void if there were an object that were assigned, which you can do. We don't have it in this case. Okay, so if nothing's passed, then nothing is assigned, and it basically is going to create a reference variable that is going to point to a place in memory that's going to contain a space holder for all those values for the instance variables. Now let's look at the parameterized constructor. You can see there's 5 strings. Well, there's 4 strings and a double that's being passed in, just as we have all of our fields. Okay, and if you look, this FN that is being passed in is going to be assigned to first name, which is going to be assigned to the private first name. Now, this is one of the reasons we use constructors to make assignments to fields for classes, is because we can't assign them directly because those are private. Now, you can see here that this FN is not very descriptive. If I had typed first name here, that would be okay, but we have a problem, and that is it confuses our program. Okay, so if you ever see this in a class, it's referring to the actual field for this class. And so if I wanted to be really descriptive, I could call it first name, but then I would have to differentiate between this first name and this first name. That is why I use the keyword this. Okay, so we've got first name being passed in, last name is going to be passed in, ID, GPA, and class. The last constructor is something in between a default and fully parameterized constructor. In this case, we're only passing in the ID. And so the ID that is passed in is going to be assigned to the field for the class, but also all the other fields for the class are going to be assigned to empty, null, or zero. The last method that we have in our class is a toString method. This is really important to include in a class because it really helps when it comes time to problem solve and fix bugs. You can check all of your assignments to your instance variables and see if there's any errors in those assignments. All right, so let's go ahead and let's use those constructors. Okay, I'm going to go to my form and double click the button, and you can see here that I have an instantiation. Okay, this is how you use the default constructor. You put the name of the class, you have a identifier, so my student object is going to be called stu1. Now notice you always have to use, with a class, you always have to use the keyword new to create a student object. And then lastly, we have the type, which is a student class or a student type. Okay, so we have the empty parameter. That's how we know that we are using the default constructor, because the parameters match. All right, so also I have my text box, my first text box, and I'm assigning the text to it of the toString. Okay, so if we are going to make assignments with a default constructor, what do you think is going to be included as data for that student? Well, let's run it and see. I'm going to click the button, and you can see that it made an assignment in memory. A reference variable called stu1 is pointing to an object in memory with all of the fields for that object, with assignments of empty if they're a string and 0 if they are a double. All right, let's try to change that. Let's go back and let's go ahead and fill in the parameterized constructor. Okay, you can see that my parameter is different. That means I'm calling the fully parameterized constructor because the compiler says, hey, that's the one that matches. And during runtime, you can see that I have a string, a string, a string, a double, and a string. Just the order and just the number that it expects. All right, now if I call the toString method on this, what do you think is going to appear in the top text box? Let's see. Okay, so there we go. We have a reference variable, stu1, that is not holding the data, but is pointing to a space in memory where the stu1 object actually resides, with all the values that are assigned here on our window that are assigned to the fields for that object. Okay, so that's how you use classes. Now let's take a minute and look at structures. Okay, so we're back in our student classes. This is where our class ends. So I'm going to come down below the class, but still in the namespace, and we're going to say struct. Okay, and just like a class, everything that belongs to that structure, the members of that structure, are going to be contained between the brackets. So let's go ahead and get started. Okay, here you see that I have created fields for the structure, instance variables. They look just the same. Okay, now here's where we get one difference in a structure and a class, and that is that a structure is not allowed to have a default constructor. You need to go ahead and make assignments to the structure, and so we're going to do that. Okay, here you see we have a parameterized constructor. Now let's make a toString. We're going to be returning a string, so we put string as the return type. Okay, we have finished our structure. We have 4 data members and 2 behavior members, 4 fields and 2 methods. Now let's go back and add the code to our form. Now I'm going to use the keyword new here, but you don't have to use the keyword new with structures, and we'll talk more about that in a second. And we're going to go ahead and put in some class names. So we have instantiated a schedule structure with the identifier of stu1 schedule. We used new, although we didn't have to, for a structure, and then we parameterized all of its fields. Let's go ahead and use it. Okay, so we have our text box.text, and we're making the assignment by using the stu1 schedule structure to call the toString method. Let's go ahead and run our program and see what happens. Okay, if we've done it correctly, the bottom text box should be full of the student schedule. And it works. All right, so you've seen a class work and you've seen a structure work. In the next unit, 2.02, we'll talk more about the differences between classes and structures and more about the role of objects and memory and object-oriented programming.